morning children, welcome back to my maths class once again. Today in my session I'll be going to teach about the segment of a circle and how to find the area of segment of a circle. Now quickly let's start the class. The tangents and secants to a circle is the chapter, 9th chapter in paper 2. Now we'll quickly have a recap of the knowledge of circles. Circle with center O. This is called the radius, and twice the radius is the diameter. Right? Area of circle. Pi r square. The perimeter, that's nothing but the circumference. Circumference is 2 pi r. And if I draw a chord AB, this is the chord AB. Keep on drawing few chords. The longest or the biggest chord is nothing but the diameter. So the diameter is the longest chord. So this is all about the circles. And let's take one more circle, center O. And this is a part of a circle. We know that. The arc ACB, the center O. This is the sector. You know this in the previous classes. Then what is the area of sector? X degrees by 360 degrees into pi r square. X degrees is the angle subtended by the arc at the center. Now, I'll shade this part, sector. Today we learn about the segment of a circle. See the circle with center O. This is the chord AB, and this part is called as the segment of the circle. That means the area bounded by the arc ACB and the chord is nothing but the segment. Segment is the area bounded by arc and the chord. This is small compared to, this is a shaded one, this is the unshaded part. So when compared to the unshaded part, if you see this shaded part, this is quite small. So that is called as a minor segment. And this part which is unshaded is the bigger part. This is called as the major segment. So I repeat, what is a segment? A segment is the area or the region bounded by the arc as well as the chord. So if you are going to take this major segment, if I get this as C, I'll name this as D. So the area bounded by the arc ADB, and the chord AB is called as the major segment. So this is all about a segment. Let's see one problem and do this. The length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 10 minutes. So this problem is a problem based on the sector. Right. Let's take one clock. 12, 3, 6, 9. So given that, find the length of the minute hand of a clock. Let's take this as a minute hand. The big one is a minute hand of a clock is 14 centimeters. And Find the area swept by the minute hand in 10 minutes. How much area it has swept? That means it has covered in 10 minutes. 10 minutes means if you take 1, 2, 5 minutes, 10 minutes. So we don't know the angle here. To find the area swept, you want the angle. So to find the angle, for 1 minute, the clock is a circular shape. The one complete rotation is 360 degrees. So for 1 minute, 360 degrees by 60, because 60 seconds, 1 minute. So for 1 minute, how much angle it subtends? 6 degrees. So for the minute hand to move 1 minute, it covers a part of 6 degrees. So for 10 minutes, 10 into 6, that is 60 degrees. So the angle here is 60. The area of the region where the minute hand has swept in the clock. So from the area of sector, we know that x degrees by 360 into pi r square. Our x degrees is the angle, 60 degrees by 360 into pi value 22 by 7 into r, that is 14 centimeters here. 14. And simplify it. 6166, likewise 717, twice, 2 ones, 2 thrice, you will be getting 22 into 14 by 3. This will come to 102.66 centimeter square if you simplify it. So the area swept by the minute's hand in 10 swept by the minute hand in 10 minutes is 102.66 square centimeters. So this is the area covered by the minute hand. This is one problem in do this, and there's one more problem in try this. How find the area of a major segment using the area of minor segment, like this. See, if you take this, we are not given any value of r, or just given area of minor segment. How to find the area of the major segment? That means here, to find the area of a major segment, we can find the area of the circle. And if we subtract the area of the minor segment from the area of the circle, we get the area of the major segment. That is one problem in your try this. Now let's quickly look upon the problems in your exercise. There is a problem in exercise 9.3. A chord of a circle of radius 12 centimeters subtends an angle 120 degrees at the center. Find the area of the minor segment of the circle. Here also given, use the pi value as 3.14 and root 3 1.732. So we have to find the minor segment area. So let's take this is a center, radius given 12 centimeters. And what's the angle? 120 degrees. So, area of the minor segment of the circle. This part we need to find, the minor segment. The shaded part. So, this is an isosceles triangle clearly because the radii 12 centimeters. Let me take the chord as AB. So, OA equals OB equals 12 centimeters. So, if you consider the triangle AOB, two sides are equal, it's an isosceles triangle. Now, to find the area of the segment, first we'll find the area of the sector and we will subtract the area of the triangle from it. So, area of minor segment. Let me also name the arc. See, ACB arc. Let's say this is as D. Area of the minor segment. This area we'll find out from the. We first find out the area of the sector, then subtract the area of the triangle. So we'll get the area of the minor segment. Area of sector. Our sector is a minor sector, that is ACBO or OACB. Subtract area of triangle AOB. From the sector, if you subtract area of triangle, you will get the area of the minor segment. Now first in this we will find the area of sector. We know the formula. Area is x degrees by 360 into pi r square. Here the angle subtended given as 120 degrees by 360 into, shall I take 22 by 7? No, because given use pi value as 3.14. So we have to use 3.14 and where r is 12 centimeters, r square. So when you simplify this, cancel it, 12 ones, 12 tries, 0, 0, 0 we can cancel, 3 ones, 3 fours. So we'll be getting 4 into 3.14 into 12. It comes up to, so when we calculate and multiply this, 150.72 square centimeters. This is the area of the sector. Now, to find the area of the isosceles triangle, first I'll drop a perpendicular here. We name as OM. OM is perpendicular drop to the chord AD. So if you consider the triangles, both the two triangles are found here. Triangle AOM is congruent to the triangle BOM. How they are congruent? I am telling that these both are congruent. Let's see. We know that the radii are equal. So one side is equal. That is OA equal to OB. And an angle here 90 degrees, or if you take these two angles are 30 degrees each. How? Because sum of all the three angles in a triangle is 180. So 180 minus 120 is 60 degrees. And these two are 30 because the angle opposite to the side should be same, because this is an isosceles triangle. So 30 and 30 degrees. So one angle is equal, angle A equal to angle B. Another angle where here this is 90 degrees. Angle AMO equal to angle BMO. It's 90 degrees. So two angles and one side. So from ASA axiom, we can say that these two triangles are congruent. I repeat, there is one angle equal, there is another angle equal 90 degrees, one more side equal. So from ASA, angle side angle axiom, we can say that these two triangles are congruent to each other. So if I want the area of the complete triangle AOB, it is the area of the triangle AMO plus the area of the triangle BMO. Or simply we can say, because these two are congruent, we can say that it is twice the area of the triangle AMO. If I find the area of the one triangle, if I make it into twice, that is the area of the triangle AOB. Now let's find the area. To find the area, what is the area of a triangle? Half base into height. So we don't know the base because the chord is not given. We don't know the height. So first we'll find the base here. Considering the triangle, one triangle AMO. Triangle AMO, if you see triangle AMO, cos 30 degrees is equal to, cos function, cos 30 degrees is equal to the adjacent by the hypotenuse. The adjacent is AM by the hypotenuse is 12 degrees. So cos 30 degrees is sin 60, that is root 3 by 2 equal to AM by 12. When 12 comes here, AM is equal to 12 root 3 by 2. That is 6 root 3 centimeters. So we got this AM as 6 root 3. So we are using the cos function because I need to find the adjacent side here. For adjacent side we should apply cos. If you want to find the opposite side, we have to apply sine value. So we'll look at that also. So we got AM as 6 root 3 centimeters. Now let us consider the triangle BMO. We want to find the height, that is OM. So here we'll take sine function because sine theta is equal to opposite by hypotenuse. So I want the opposite side here. Sine 30 degrees is equal to OM by the hypotenuse 12. Sine 30 is 1 by 2, OM by 12. So OM value is equal to, if it comes here, 6 centimeters. So the height of the triangle is 6 centimeters. This AM is the base. So we will find the area of the triangle. Area of the triangle AMO. Half base into height, that is equal to 1 by 2 into 6 root 3 into 6. This is the base, it's the height we found out. So 3. So 18 root 3. Also in the question, root 3 value is given 18 into 1.732. This comes up to 31.17 square centimeters. This is the area of the triangle AMO. I want the area of the triangle AOB. This is twice AMO. So area of the triangle AOB is twice 31.17. Comes up to 62.35 centimeter square. So this is the area of the triangle, and we know that area of the sector is 150. So we'll find the area of the segment. Area of minor segment is equal to, we got the area of the sector as 150.17 minus the area of our triangle, 62.35. We'll get the area of the, so 150 minus 62, it comes up somewhere up to 88.68 square centimeters. This is the area of the minor segment. So if in this problem, if it is asked about the area of a major segment, if they ask, this is the unshaded part, major segment, simply you have to find the area of the sector and add to that area of the triangle. If you add these two, you get the area of the complete major segment. So likewise, we'll see one more problem. We'll see one problem in the exercise. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle 115 degrees. Find the total area cleaned at each sweep of the blades. Also given that use pi value as 22/7. That means a car has two wipers which are not overlapping. Each wiper is sweeping, each wiper of length 25 centimeters. It is sweeping through an angle of 115 degrees. The wipers which are used in the car for removing the droplets. The total area cleaned at each sweep. For one sweep, how much is the total area cleaned? That we need to find out. Let us assume this as the car window pane. This is the area. Let me take one wiper here, the other wiper. They are simultaneously working. So, find the total area cleaned at each sweep. For one sweep, how much area it cleaned? So, this area as well as this area we need to find. So, first we are given the length of the blade of the wiper, that is, this is 12 centimeters. No, 25 centimeters. So, how much angle it's making? 150 degrees. So, for one wiper 115 degrees, the other wiper 115 degrees. Totally, for one sweeps by both the wipers, the angle subtended is 230. For one sweep, this wiper as well as this wiper, 115, we get 230 degrees is the angle swept. So, we will find the area of the sector. Here, our sector, we cannot draw it. We have to assume the part of the circle because the wiper is at the center of the circle. The part of the circle which is swept. So, area of the sector is x degrees by 360 into pi r square. So, here x degrees is 230 degrees by 360 into pi value given. Substitute as 22/7. R value is 25 into 25. You cancel it and you simplify. It comes up to 1255 square centimeters. So the area swept by the wipers for each sweep, for one sweep, is equal to 1255 square centimeters. So like this we can solve the problems from regarding the segment of a circle. So children, hope you understood today's class. Please subscribe to the channel and share among your friends. Thank you all.